All right, so hopefully this works and hopefully it makes sense. I intended to do this video probably 2 or 3 days ago when it was beautiful outside, but my chickens, well, I decided to do the video outside, but my chickens decided to just talk. So anyway, now that we have a little bit of quiet time, I want to talk about standard distribution or standard deviation. So when we're talking about standard deviation, we have two different scenarios where we're going to be looking at this particular idea. So we're going to be looking at it from a sample perspective and from a population perspective. And if you're watching this, chances are you've already delved into the difference between sample and population. Population is everything, every element. Sample is a subset of that grouping. So you'll notice that the equations are relatively similar, and there's going to be some things in those equations that we're going to have to pick apart. So some things to think about here. Here's our standard deviation of a sample on the left, standard deviation of population on the right. When you look at this big E symbol, that means summation. So what we're going to end up doing is we're going to do a handful of computations, and we're going to add all of those together once we're at the end. Hopefully I can show you how to construct that using Excel. Now, one thing we need in order to calculate the standard deviation for both the sample and the population is we need the mean. So for a sample X bar is how we would denote the mean, and then for a population, mu, this funky looking U here, is how we would signify the mean. So what I've got going on here on the right hand side of the screen, it's M&Ms. So we have red, green, orange, blue, yellow, and brown. Those are the colors of the M&Ms, and then the frequency here is 8 reds, 9 greens, 14 orange, 9 blue, 10 yellow, and 10 brown. And what I did is I used an online simulator that would automatically generate M&Ms so I could come and do some analysis. So obviously these M&Ms do not represent the entire population, so they would represent the set. So that tells me we would utilize this equation here on the left. So a couple of things here. N, little n is going to be the number of elements in the sample. Big N would be the number of elements in the population. So we'll talk about that in a second. So what we need to do first is we need to calculate the mean. So what we're going to do is we're going to highlight all of these cells, and we're going to go to this auto sum feature, and we're going to click average. So the average, or the sum, or the mean of these is 10. Now if I wanted to find out the total number of elements in the set, I could do that first by highlighting all the cells and clicking sum. So that tells me that there are 60 M&Ms in this data set. We can check our work here to make sure that we added them up correctly. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. 7 times 8 is 56, plus 4 is 60. Makes sense. So we know in this case our N is 60. And then if we wanted to find the mean, we could do that right here by clicking AutoSum average. So in this case, the mean, or if we go back to our equation, X bar is going to be equal to 10. Now one part of this work is we could also calculate the relative frequency. So essentially the relative frequency is the ratio of the frequency and the total number of elements in the set. So what I can do, if I want to calculate the relative frequency, I click the equal sign, and that's how we start writing equations in Excel. Then I'm going to click the contents in cell B3, and I'm going to divide that by 60. So that's going to give me the relative frequency of the red. And then if I wanted to apply this formula to every color, I'd click in cell C3, click on the right-hand corner where it has a little plus, and then I would drag it down. The cool thing about relative frequency is if we add it all up, it's going to add up to 1. So if we do that work and take the sum of all of these relative frequencies and it adds up to 1, that tells me that we are in really good shape. So what we're doing now is we're just compiling all of the elements that we need in order to calculate the standard deviation. So we need our X values, so that's what we're going to get in the frequency. So that's X. And X bar is going to be the mean, which I've denoted down here at the bottom, and we've calculated that. I suppose I could put X bar here, and then format it in such a way that makes sense. My cells are my screen is a little bit truncated, so it's a little bit harder to find the right menu. Anyway, now the thing of it is we need to find the difference of the x and x bar for each element. So what we're actually going to do is we're going to take our e, or equal sign, then we're going to click the x value minus, and then in this case x bar is 10 because that's the mean. So the difference of the x value and the x bar is equal to -2. Now if I wanted to apply that to every number in this column, all I would need to do is click on the plus, the right hand corner on the bottom, and drag it down, which makes sense. So 8 minus 10 is 2, 9 minus or -2, 9 minus 10 is -1, 14 minus 10 is 4, 9 minus 10 is -1, 10 minus 10 is 0, 10 minus 10 is 0. So what we've done here is we've gotten the x minus x bar. Now what we need to do is we need to apply this squared bit. So when we square things, we're essentially multiplying a number by itself. So in this case, -2 squared is 4. So what we're doing is we're taking this x minus x bar and we're squaring it. And we're going to apply that rule to each one of these situations. Okay? So we have -2 squared is 4, -1 squared is 1, 4 squared is 16, -1 squared is 1, 0 squared is 0, so on and so forth. Now this notation here, sigma, means summation. So once we've done all the x minus x bar squared, each of those individual computations, what we're going to want to do is we're going to want to take the sum of those values. So we're going to highlight all of the elements in that particular sequence, and then go to formula, auto sum. So the sum of those values is equal to 22. So essentially everything in this cell right here, that 22, is what you have in the numerator. So what we can do next is we can take the square root by clicking equal, type in square root, and then we're going to take this value divided by our n minus 1. In this case, n represents the number of elements in the sample, so it's 60, and we're going to divide that by n minus 1, which is 59. So the actual standard deviation is going to be 0.16064, and we could round that to the nearest hundredths place if we wanted to, which would be -0.61. So there's a standard deviation right there of your sample. So that tells me that the mean is 10 and the standard deviation is 0.61. And we can do some other inferences there, but the point of this video is just to give you a basic overview of the steps that you need to take in order to calculate the standard deviation. So the first step would be to calculate to determine the number of elements in your set and determine whether or not you're dealing with a sample or a population. So once you've defined your n value, you then want to calculate your x bar, or your mu, which is your mean, and that'll vary depending on whether you're working with a sample or a population. And then what we do is we just run the computation of the x value here minus the mean, and we square it. And then once we've completed those computations, you add them all together, and that's what's in your numerator. You divide that value by n minus 1 if you're working with a population, or n, and then you just take the square root of that quotient. Hopefully this was helpful. Hopefully it didn't make more confusion than what was necessary. Let me know if you have any additional feedback or need any additional clarification, and I will be super happy to help you out. All right, that's it for now. Be good. We'll talk to you later.